Hey everyone, welcome to the Navigator's final milestone presentation by Sergio, who has been working on an account abstraction MVP for Mina Protocol. Thanks for joining, Sergio. Over to you.
Thanks. Yeah, so first maybe let's talk about a little bit about like what account abstraction is and why it's interesting to have it. So I think a good way of thinking about it is just account abstraction allows you to interact with a blockchain without necessarily knowing that you're interacting with a blockchain. And why this is interesting, as we'll see, is that a big sort of problem that comes to mind is dealing with private keys. Um, it's something that if you have to have a private key secured in order to properly sort of interact with a blockchain, that can be a bit of a nuisance. And so ideally you might want to make use of existing hardware and other people's devices, so you don't have to reinvent the wheel there. And there, I think that's sort of like a good kind of like overview of why this is interesting. And but there's many other kind of like use cases. So for example, maybe not so much just like a private key management. Maybe the application doesn't really require something so secure. You could maybe log in with your Google account or with your Twitter or like stuff like that, and really be able to interact with all these protocols essentially in like the same fashion, but not having to deal with all the additional hurdles, just like sort of the login with Google that we're all used to, stuff like that. So it's like very, very seamless. Um, so maybe that with that out of the way, I guess I prepared like a little bit of a presentation, because they don't want to get it like too technical really. I think this should be like an interesting little overview. Let me know you can see it.
Yeah, it's just coming up. Yep,
Okay,
you can
great.
see it.
Um, okay, yeah. So, well, I'm gonna go over. It's just gonna be like a quick, sort of presentation. I think it's most interesting if we like discuss some things later on. But yeah, so a bit like the motivation, which is kind of like what I've been talking about. Some use cases where this might kind of like come in handy. Perhaps like mostly oriented toward Mina, mostly an architectural overview, and I don't want to get it like too technical there. If someone else is interested, they can hit me up later. And then like limitations of this work, really. And we'll see how this could be potentially worked around if some changes were made to O1.js, which I'm not truly clear about, but we'll open that up to discussion later. So I guess, yeah, like, I mean, the motivation is just essentially what I just mentioned before. It's just, I mean, you could say it's the greatest hurdle. I mean, I think in my opinion, it is really just dealing with your private keys and keeping them managed and like properly secure, especially if you're dealing with like sensible information or large amounts of money. That is becomes a bigger problem. But this is something that has been largely solved, right? I think everyone here in the smartphones, you guys have like in a secure enclave, as is the case with iPhone, like an analogous sort of the device chip in Android phones, which is essentially what it does is that it keeps the private key very, very secure inside your smartphone. And it does all the cryptographic operations that you might be interested in, right? Like, so you just think about like digital signatures, right? So this is largely a solved problem outside the world of crypto. The problem here is that we cannot make use of this because the signature scheme that all the secure enclaves use is not the signature scheme used by Ethereum, and it's not the signature scheme used by Mina. So there's a mismatch there at every level, right? And that's why you have to buy this kind of like hardware wallet, which is actually able to perform these signatures natively. So that's the idea with this. That was the idea with this project, really. It's just enable the ability to interact with Mina using non-custodial accounts that could just act as an account, right? And just validate user operations using non-native signature. So a user can just sign with their device and the account just works the same way and it interacts with the blockchain the same way. But at no point do they have to download any additional sort of software. And I think like two kind of like interesting examples here. One that I really like is Dymo Pay, which is just a non-custodial wallet, lets you do payments with anybody, anywhere in the world. And you just need to download the app. You don't need to do anything else, right? The key management is in your phone. That's it. And applications like Open Passport as well, where you can sort of prove elements about your identity, like your nationality, or maybe just that you're over a certain age. And well, this could be leveraged with some other application, but then again, like how do you send these signatures to the blockchain? It's with this kind of a scheme, you get like, yeah, essentially it allows people to just have to download this application, nothing extra there. So this is kind of like what I worked on primarily was the demo use case that I built was something similar to Dymo that just allows you to do payments, but these other use cases you could implement something similar, essentially, like identity protocols or like more complex apps. Like I'm thinking like CK email or any kind of like consumer app there. So I guess let's go a bit into the architecture overview. Now the project is based on Ethereum's ERC 4337. So now the way that works in like a very, very rough, I want to get too technical here, but essentially users just sign operations using a non-native signature scheme. These operations get bundled together, and it gets into this entry point, which acts as like the meeting point of everything. And each of these operations are validated by the user's account contract. Now, the account contract is just a smart contract that essentially acts on behalf of the user, right? And essentially, well, there's a fee element going on here, right? Because the transaction still has like a gas cost associated with it. So the user sort of signs like a fee, or maybe that you can have a paymaster to waive this fee additionally. And then so the account contract is actually the one that executes the operation, right? It's how it is acting on the user's behalf, right? And so this, in the case of Ethereum, this plugs in very, very neatly to all existing infrastructure. There's no changes that need to be made. It works right. With Mina, it's a little bit different because of how the blockchain is defined, essentially. So there's some changes that have to come in there to have a similar working product. And this is essentially what I built. Well, you have an account contract that kind of, effectively just acts as on the user's behalf. It represents a user's account. So what this account contract can do is it can validate a user operation and execute it. And in this case, it's just sending Mina. It's just for Mina transfers, right? And then just verify some arbitrary signature. And then you have an entry point which just acts as the central hub for all accounts, right? So here we manage the account nonces to avoid replays. We keep account of the fee balance. So every time a user sends an operation, there's a fee associated with that operation. The entry point debits that fee from the account's balance, or you can have a paymaster to cover the fees as well. So right now the project is sort of implements two main signature schemes, which are SECP 256K1, which is the one from Ethereum, and R1, which is the one that your phone probably has installed inside the secure enclave. And so now the reason why this ERC 4337 is not possible to just plug it in is due to two main limitations. The first one of which I think is the smaller one of them. We'll see that there might be like a workaround here, but essentially it's just due to the static nature of circuits. Essentially, you cannot execute arbitrary logic, right? You have to define what you're gonna be executing, And so what that means is effectively, so you need an account abstraction scheme per CK app, right? If a CK app is in this case, it's just to send a recipient some amount, well, you can just define this kind of like structure here. If you need some more complicated operation where you might have to add here, well, like an amount and a fee and like some other kind of like call data. But the other second bigger limitation is the lack of a message.sender, of an analogous message.sender in Mina. And the issue with this is that the contract cannot act as an account. So what do I mean by this? You're not able to know, you're not able to assert that a certain call originated from a given smart contract. And because you're not able to do that, you cannot, an account cannot, a smart contract cannot act on behalf of an account, right? Usually what you would do is you can verify that the call originates from a caller by verifying their signature. This is not something that you can do in this sense. So because of these kind of like limitations, each CK app needs to sort of be built around their own account abstraction and not the other way around. You cannot have an account abstraction scheme that is built for many different CK apps. But I think, and this is something that is not there sort of available. I don't know if it would be possible to add something like this to O1JS, but if you had something like this, you could define something that is like pseudo general purpose. So instead of just having a call data, a user operation that is like very, very specific, you can have something that is kind of like more general, which just define an array of fields, and then each CK app that wishes to that wishes to operate with this, they can have their own interface where they would parse these data fields into the appropriate arguments and then sort of take it from there. And that's pretty much it. So I think it would be interesting to have some discussion now. If not, yeah, you can check out the repo here. And yeah.
Cool. Thanks, Sergio. I mean, if there are any questions in the audience, please feel free to come on the stage or type it in the chat. And I think there might be a message over here. Oh, no, it's just Fireflies. Yeah, so I guess one of the questions I have is, let's say if someone wants to try, I guess, the implementation out right now, could you walk us through the steps on what they would need to do to integrate it? And I guess the second thing, you might have already covered this, is like, does this implementation currently only support payments, or is it possible to define any arbitrary user operation codes for a ZK app and test this out?
Right. Well, I think I'm gonna start with the second question. Yeah, right now it only supports payments because kind of like what I was covering. Yeah, it's effectively that you have to design, because of these limitations, you have to design the application around the account abstraction, right? And so this is kind of like the simplest case I guess that you can think of is just having something like this. So you could potentially, yeah, you could effectively, with the scheme that is designed, you could modify it to do something a bit, yeah, something different. The issue is just that, like, you have to sort of think. That's the main limitation, is that you have to think for each application how would you want to do this. Like, is something, is the account, so in this case the accounts hold the balance, right? Because this is just sending Mina transfers back and forth. The actual account smart contract holds the Mina balance. But if you want to execute some logic, maybe you would want the logic to reside at the entry point and not at the account contract. I think there's like some considerations there that you need to that you need to have. And then as per using it, well, the contract right now, as is, it allows you to do payments already. So I guess like you would need to deploy it basically. I'm not sure like the question.
Yeah, I mean, I guess is there like documentation that someone can follow to integrate this, or?
Yeah. There's like a there are like some docs on the. I don't know if I could share it maybe. Yeah, it's like a little bit like docs here, like what is like going on,
Mhm.
like all the different calls here, a bit of, like limitations too. So yeah.
Cool. Thank you. Carol?
Hi there, Sergio. Thanks for that. Just quick question. How expensive in terms of constraints is it? Is there much room to add any extra logic within the transaction? Do you know?
I might have to get you back on that.
Okay,
I can't,
no worries.
yeah, but like extra logic, I think there's some optimizations that might be possible. Again, like it depends on what you're trying to do.
Yeah, I'm just more thinking instead of optimization is there a enough space to send something else than send transaction and maybe hard code exactly the one single ZK app you want to interact with. I wonder if there will be enough space on the constraints to do it within the transaction. But
yeah, I might have to get you back on that. But like the real sort of constraint here is not so much what you're running here, like this call data. The real kind of blocker is just the actual cryptography going on, right? Like the signature scheme, like that's what eats up the vast part of it. So
yeah, that's
I'm not
what I
sure.
expect.
I'm not sure if you have much space left over to sort of like constraints, but yeah, this is if you want to add like another couple fields there, it's honestly not going to be as big of a blocker. Yeah.
What about amount of account updates that are happening?
Amount of account updates, I believe. Well, that would be your. So this the entry point that manages the nonces, right? Which is sort of you have to update that. It's like on off chain storage going on, and then the account contract too, and then well the recipient of the. Then there's the recipient of the payment, and then it depends on like if you're using like a paymaster or not. There's like another sort of color there in the fee, so maybe like maybe like 5 in total.
Yeah, I see. On the edge, but yeah, that makes sense. Cool. I might play around and like give you my feedback when I do.
Sure.
Yeah, thanks very much for doing that work. It's very exciting to have that actually in Mina. That's good.
Sergio, could you please go to the slide before this? I guess I have, yeah, and in this one, could you please explain, so for example, if I have my mobile phone and I want to basically use, as a user, I want to use account abstraction, what are the steps the developer needs to take? So I see like there are like a couple of important components over here. We have an entry point, an account, a factory. So who's responsible for deploying what? And is there like a one-one mapping between my enclave keys and the factory deployed account by the ZK app? Is that the design?
Can you repeat that again? One-way mapping between the.
Yeah. So let's say there are like 3 different ZK apps which are using account abstraction, and I want to interact with all of them. So will each ZK app developer need to deploy their own account abstraction interface for my account, or will they deploy just one interface which can be used by multiple accounts in the ecosystem?
I mean, I guess coming back to like the sort of the limitations here, it would depend on like how these are made essentially, but you could potentially have just one account that can interact with well, essentially it would really be just the entry point that can interact with the 3 different applications in that case. And yeah, just from your account's contract, you could, with the same kind of, you could sign the same, you could sign operation for all 3 of them, and it could just all be managed from a central entry point by those 3. But it would kind of have to depend on the application there. I'm not sure, like, yeah, and like as per like what you need to deploy. So this is how the how the scheme kind of works for Ethereum. Mina would work a little bit different, but effectively, like you deploy an account, which is just like your rep, like it acts on your behalf, right? So the account kind of like registers what your public key is, not your Mina public key, but like on this other signature scheme, whatever. And then you have like a central entry point. So it's really kind of like works kind of like this. Yeah.
Gotcha. Thank you. I'm just waiting for if there's any questions from the audience. Please feel free. Nothing so far. So I guess maybe one question would be, is there like, apart from payments, is there any other ZK app you think which can be built quite easily to demonstrate, this abstraction? I know there's like multiple issues that you've highlighted using the inability of message.sender and like using a static circuit, which is in some ways a workaround would be to like deploy like a contract which is very specific to a ZK app. So is there something you feel can be integrated quite easily, or do you have like a demo of anything else apart from payments plan?
I think something like an identity protocol could be kind of like interesting. Yeah, because I mean, effectively, how you would do that on Mina right now, right? You gotta have you have like your so your anonymity sets deployed there on Mina, and when you send it, you just send a transaction to the smart contract directly, and you prove that you're, I don't know, over 18, something like that. I think, but that implies you interacting with the blockchain, so you have to deal with like an additional set of keys. I think something like this could be interesting to add, and I think it could be added sort of easily, like a bit, yeah, because you have like a lot of the existing stuff there. I think that's what I would be sort of, yeah, if I had to sort of continue, yeah, like I think that would be like a next step. But then I would like to sort of see this be discussed more like in depth by the sort of, yeah, the dev team, because I have been kind of like researching this, and I'm not sure, I got the impression that maybe it would be possible, but it's just not implemented. And yeah, it's just something that I don't, it's something that I think you could, if you had this, you could have something that's very, very general purpose, just having something like this kind of like general purpose goal data. But without it, it's the biggest blocker. Without it, you have to design each app around your account abstraction.
Gotcha. Thank you. And I guess maybe the last question I have is there any, because I know sometimes there's like account abstractions which deal with stateful and statelessness. So which basically means, can I write something which says this transaction is only valid until like block 500? Can states be managed in the current implementation, or is this something which is like needs to grow further down the line?
I mean, you could add this like very kind of like in this in this call data here. Yeah, you could sort of have there like a time limit essentially.
Okay.
So when the account executes this, like all it does is just sends this value to the recipient, right? But you could add like an extra check for stuff like that. It would be quite simple.
Okay.
Yeah.
Cool. Awesome. So I don't have any more questions. I'm just going to give a second to take a look at the chat. No, there's no questions from the audience. So thank you, Sergio, for the presentation, and thank you everyone for joining.
Yeah. Thanks for your time.
Thank you, guys. Bye.
Thank you very much. Cheers, man. Hi.
Take care.